All right, so this final lesson essentially asks you to describe the game loop and to really get a strong understanding of what's happening as a result of the game loop that is built into MonoGame. So by the end of this lesson, you will have some good practice tracing through values and telling me what's happening as the game loop is running, and then writing some code based on game loop data that you see. So that's what our goal is by the end of today, that you can really have a strong understanding of how that game loop functions and how that game loop works with your variables and objects and everything like that to redraw your screen and to update your values. All right, so you should have this handout in front of you. You will be expected to fill this out on assessment so that I can see that you truly understand what's happening as the game loop runs. But ultimately what you see here is you can see that you have the update method off to the side. So this is all the code contained in your update method. And this is the code contained in your draw method. So if we take a look at it, we can see that every time update runs, red, green, and blue are incrementing, and then we have a conditional that is checking the value for red and then resetting it essentially as the program runs so that it cycles between 0, 1, 2, 3, 4, and 5. And then down on the draw method is drawing to the screen the color that we're creating. So basically what I want to see in these columns here is I want to see what red, green, and blue are equal to at the end of every run of update. So this is at the end. I'm not asking for what they're equal to at the beginning. I'm saying at the end of the first 60th of a second, what are red, green, and blue equal to? At the end of 2/60th of a second, what are red, green, and blue equal to? So if we start, we know, and this is an example, this is in your instructions at the very, very top, we know that to start, red, green, and blue are equal to 0, 0, and 0. So now we're going to start, and the first time we run through update, we can see, okay, red is incrementing by 1, so red becomes 1, green becomes 1, blue becomes 1. And then we get to this conditional right here, red is not equal to 5, so I can skip that piece, and I'm done at the bottom of my code at the first 60th of a second. And then I go back, and I go to the second 60th of a second. Okay, I increment red and green and blue by 1 each. I check the conditional, nope, red is not equal to 5, so I go to the bottom of my code, and that is the second 60th of a second. Now from here, I'm going to do the same thing. Okay, third 60th of a second, I'm running through again, so I have 3, 3, 3. It's not equal to 5 here, so I go to the bottom of my code, and that's the third 60th of a second. And then from here again, okay, the fourth 60th of a second, this is 4, 4, 4. Again, not equal to 5, so continue down. All right, that's the fourth 60th of a second. Now from here, I know that as I'm running my fifth 60th of a second, this becomes 5, 5, and 5, but it says if r is equal to 5. Well, hang on, this is true. So because this is true, r actually gets changed to 0 before the end of the program. So what I will kind of expect to see is, you can see in that first column, I wrote 5, but then it changed to 0, and at the end of the program, I want to know what at the end of update, at the end of that 5/60th of a second, what red is equal to. So I'll expect to see that it was 5, but that it did change, in fact, to 0. And now if I keep going, I can do all of this the same, so this becomes 1, 6, 6, 2, 7, 7, 3, 8, 8, 4, 9, 9, 5, 10, 10, and then r is in fact equal to 5 again, so it gets changed to 0 because of this conditional right here. So really keep in mind of what the game loop is looking for, what's happening, what's rewriting, and how are those values actually changing as your program runs. All right, so what I'd like you to do is pause the video here, and what I'd like you to do is try and trace through this on your own. So as you're going through, trace through the code. You should be crossing off and changing red, green, blue, etc. as certain values are changing as a result of those conditionals. And then once you're done, pause the video, and I can walk you through quickly what your tracing off on the right-hand side in that table should look like. So again, what you should be doing is tracing through this on your own and then double-checking your answer afterwards. All right, so again, remember to start these, if you look in your handout, start off at 0, 0, and 0. So keep that in mind as we move forward. So I can see every time red is incrementing by 2, green is incrementing by 3, and blue is incrementing by 4. So as I go through, okay, R equals R plus 2. So this has become 2, this has become 3, B has become 4, okay. Is G times 2, so 3 times 2 equal to 12? Nope. Is R equal to 6? Nope. So I come back through, okay, I'm going through for the second 60th of a second. R is 4, G is now 6, B is now 8. And is G times 2 equal to 12? Well, hey, that is true. 6 times 2 is equal to 12. So I can see that G is changing to 0, and B is equaling B times 2. So G is 0 there, and this turns into 16. All right, is R equal to 6? Nope, that is not the case. So I can see there that I'm done for the second 60th of a second. Now from here, I'm going to run the third 60th of a second. So I'm going to go through, okay, R is equal to 6. G is now equal to 3. B is adding 4, so that's now equal to 20. Remember that was 16 earlier. My 1 and my 6 kind of blended together. And then from here, okay, G times 2 equals 12. Nope, that is not the case. If R is equal to 6, well, hey, R is equal to 6 in this case, so R is rewriting to 0, and B is rewriting to 0. So I can see at the end of 3/60th of a second, R is currently equal to 0, G is equal to 3, and B is equal to 0. So my values are much smaller than what they used to be. Then from here I go through again. Okay, R is 2, G is 6, B is 4. Well, I can see here that that first conditional is true, so that G gets rewritten to be 0, and B gets rewritten to be B times 2, which is 8. Then from here, okay, R is not equal to 6, so now I'm on to the fifth 60th of a second. Okay, 4, 3, we have 12. First conditional is not true, second conditional not true, done with the 5/60ths of a second. Okay, loop back up, I have 6, 6, and 16. Well, now I see that first conditional is in fact true, so G times 2 is equal to 12. So I'm going to rewrite G to be 0, B to be 32. But then I can also see that that second conditional is true. So R is equal to 6, so R gets rewritten to 0. We've got a really unique case here where B is rewritten again to be 0. So at the end of 6/60th of a second, because of all the changes that have taken place, we actually have 0 for red intensity, 0 for green intensity, and 0 for blue intensity. So we're kind of back to where we started at the very, very beginning. So now from here, we keep going. We have 2, 3, 4. Neither of the conditionals are true. And then here we have 4, 6, 8. Well, that first conditional is true, so G gets rewritten to 0. B gets rewritten to be 16. The second conditional is not true. So now we have 6, 3, 20. That first conditional right here, not true. The second conditional is true. R is equal to 6, so this gets rewritten to 0. This blue gets rewritten to 0 as well. Then we run it through one more time. Okay, 2, 6, 4. Okay, G times 2 is in fact equal to 12, so that first conditional is true. So that gets rewritten to 0. And B gets rewritten to 8. So I can see that at the end of 10/60th of a second, a lot of changes have taken place throughout, but at the end of 10/60th, so I'll write this down so we can see it. At the end of 10/60th of a second, R is equal to 2, green is equal to 0, and blue is in fact equal to 8 based on all those changes that have taken place. So you can see that how even really simple conditionals can cause a lot of changes throughout. And remember, in your table, what I ultimately want to see is at the end of each 60th of a second, what are those values going to be equal to? So be really careful as you trace. Be very neat. I would suggest using pencil so that in case you make any mistakes along the way, you can in fact fix them. All right, so the last thing that you need to be able to do is you need to be able to write the code for a game loop representation in a table as well. So there are actually a lot of ways you can do that. It's ultimately up to you. I'm going to show you how I generally pick through it and what I do. But again, as long as your code works, I will check it. As long as your code works, you are good to go. So from here, we can first see, and we know from the handout that you have, that R starts off equal to 0, blue starts off equal to 0, and green starts off equal to 0. So before I write any code, I kind of go through and I look and I see what's happening. And so if I look at red, I can see, okay, red is adding, looks like to be 10 every time. However, when I get to 6/60ths of a second, I expect this to be 60, but really I'm getting 100. So there's got to be some sort of change taking place there. Then if I look at G appears to be incrementing by 10 every time. However, when I get to that same 6/60ths of a second, I essentially expect G to be equal to 60, but for some reason it's equal to 0. And then here, well, I can see B is incrementing by 5 every time, and at 4/60ths of a second, I expect this pattern to be 20, but I have 0 instead. So I kind of go through and look at what changes are taking place, what I would expect, and what changes are kind of throwing me off. So for example, I made those notes in the middle of the table saying I would expect 60, or I would expect 20, or I would expect whatever. And then from there, once I've made all those notes, I go over and I can write my code. So I'm going to write my update method code over here. The first thing I want to do is I want to write down the changes that are taking place with R, G, and B throughout the code. So I'm going to say, okay, well, it's R, excuse me. R is equal to R plus 10. So each time this program is running, R is increasing by 10. G is equal to G plus 10 as well. And B is equal to B plus 10, or 5, excuse me. So I have those changes documented. So I've taken care of these 3 components. Then from here, what I try and do is I try and account for all those areas where I expected something. So this big change where I expected something different tells me there's a conditional taking place. So I expected 60, but as a result got 100. So really what's happening here, remember when we were crossing off those numbers saying, oh, we incremented by 10 to 60, but then it was changed to 100. So really what's happening here is I'm saying, well, if R is equal to 60, that's what I expected it to be. What happens is instead, R is set equal to 100, and it's changed by the end of that code. So I expected 60, but when R was equal to 60 after its incrementation from 50 to 60, it changed to 100. Then from here, I do the same thing with row G. I say, well, I expected 60 right here. So really what must have happened is I changed this to 60, but then it got changed to 0. So here I can write, well, if G is equal to 60, that's what I expected, G gets incremented and changed then to 0. So it gets incremented to 60, and then when it's equal to 60, it gets changed to 0, and that's why at the end of my 60th of a second, I see 0. Then the other piece that I can see, and I'm going to choose a different color here, so let's choose an orange to make that easier to see. I'm going to choose an orange color. All right, there we go. So I expected to see 20 there, but instead I saw 0. So what that's saying here is that this was 20, but it got crossed off. So it's the same process as before. If my B value was equal to 20, that's what I expected it to be. It increments to 20 as a result of adding 5 every time. But when it's equal to 20, B is in fact reset to 0. So now I can see how my update method is in fact changing my variables. It's incrementing them every time, and then when it reaches a specific value, it changes differently than I expected it simply based on those incrementations. So you need to be able to write code that matches the game loop table as well to show me that you really do understand how that game loop works. So be prepared as you move forward. I will be asking you to write code. It's always smart to double check, maybe create a little table off to the side double check based on the code that you wrote that this does in fact work as expected. So you should hopefully now have a good understanding of the game loop, and now you're ready for your assignment. And so you can practice those skills. Do you really understand how to trace the game loop code? And then can you work backwards and take the values that were found out of the game loop after each 60th of a second and write the code for them?